can't. It like it hurts my soul to have a free day.
Really?
Yeah, it does. Nothing pains me more than us sitting here doing nothing, staring at each other. Ugh. Drives me nuts. Okay, so we're continuing our notes. We're on 5-1. We're on example 4. So this is the calculator section. So just get your calculator out. I think you're in radian mode. Yeah, I want you to go back to radians. This is a chapter where you have to flip-flop a lot between radians and degrees. It's just, you got to do it sometime. So change to radians, and let's put these in our calculator. Oh, I'm glad. I've been wondering where's the... It's been sitting here for weeks. I'm like, I have no idea whose it is. All right. So I got 1.124 for the first one. That's the angle in radians. Yes? What about part B? It says arc cosine. Does that mean we freak out? No, it's the same as inverse cosine. $2.8585685. Uh-oh. What does that mean? Does not exist. Means we can't do it. It's out of our domain. It does not work. How do we do cosecant?
Wait, but is it cosine 0 to pi?
But is the inverse the negative 1 to 1? I have to look every time. The inverse is from negative 1 to 1. Is that okay? Like with the calculator ones, if the calculator gives you the error, just assume it's out of the domain. Is that okay? Okay. What'd you get for this one? How do you do this one? So this is where you go 1 over sine of the inverse cosine, right? What'd you guys get here? Does it let us do it? I don't know why it lets us do some of this. If it's a calculator one and your calculator gives you a number, just go with it. I don't know. Let's roll with it. I just put it in my calculator and that's what it gave me.
Okay. But it's 3.5.
I know. I don't know why it's doing that on some and not on others. I don't know why. Didn't you get some before you left?
No, you just gave me a little square piece of paper with what we were going to do.
I had
supposed to be here yesterday, but our flight got delayed 2 hours.
Maybe not. Okay, so next time don't wait until I've started, like, and gone all the way through my example. Okay, So let's look at example 5a. Now I did add examples on these two because I think the more you see it, the better off you are. Okay. So what we're gonna do with these? Do you notice on the inside here we have two different inverse functions? So, like I said yesterday, the beautiful thing about math is I can replace with whatever I want to replace, right? So what I'm going to do is I'm going to say, well, I want x to equal the inverse sine of 3/5, and I want y to equal the inverse cosine of 4/5. And I can do that. I can say I'm going to let that be x. I'm going to let that be y. I'm more than allowed to do that. And so what we really have right here is we have the cosine, but instead of inverse sine, I let that be x, minus, and instead of inverse cosine, I'll let that be y. Well, that's an identity from the last chapter. It's a difference identity, right?
Yeah.
So let's list out our difference identity. Cosine x, cosine y, plus sine x, sine y. And we can figure this out based off of this right here. We can find our triangles. I graded your quizzes yesterday. Some of you guys are replacing the angle with the ratio of the sides. The ratio of the sides does not equal the angle. The sine of the angle equals the ratio of the sides. Okay, you have to replace the whole sine of x with the ratio. So I'm going to reemphasize this. Don't replace the angle. The angle isn't the ratio, okay? Okay. So, from these, we're going to build our triangle. So let's do the x one first. The inverse sine. We are allowed to be in quadrant 1 or quadrant 4. This is positive, so we're in quadrant 1. And the sine is opposite over hypotenuse. So what's the missing leg? It's positive.
Oh, wait, just kidding.
Is that okay? What's the missing leg? 4. Good. And then can we draw our y triangle? So cosine is either in quadrant 1 or 2. It's positive, so we're in quadrant 1. And cosine is adjacent over hypotenuse. Oh, they happen to be the same. They're not always the same triangle. Don't make that assumption. Okay? All right. So my angle is x over here, and my angle is y over here. So now what we're going to do is we're going to use the ratios. So cosine of x. So go to your x triangle. What's cosine of x equal to? 4/5. Now am I going to replace x or the whole thing? The whole thing. And then we need to replace cosine of y. So go to your y triangle. 4/5. Plus sine of x. 3/5. And then the sine of y. 3/5. And now we're just multiplying. So what do we get here? Plus, which is 25/25, which is 1. Is that okay? Okay. So now for example B, it's the same idea. There is a 2 in here, but I'm not going to include the 2 with what I'm going to replace just the inverse cosine. What am I going to let it be? X. I'm going to let x represent this. Notice I didn't include the 2. Just the inverse function. Is that okay? So really what we have now is we have the sine of 2x. Well, sine of 2x, we have an identity for that. What's the sine of 2x equal? Yeah. I replace the inverse cosine with x. I let x equal that. So I just, instead of writing inverse cosine, I just put an x. Is that okay? Okay. And what are we going to do with this? Draw our triangle. So it's positive, so it has to be in quadrant 1. And cosine is adjacent over hypotenuse. So what's the opposite side? 4. Now we're going to replace with our ratios. So we're going to have 2 times, now instead of the sine of x, now remember I'm not just placing x, I'm replacing the ratio. It's 4/5. And cosine of x is 3/5. And if you want to write that as 2/1, feel free. 24/5? 25. Oh, really close to 1. But not quite. It's a sliver away. Are we okay with that? Okay. Okay, so now it's onward to tangents. They must have been at the beach because they're tangents. Ah. You laugh? Yeah, yeah. No, nothing. Some of you, I like it. Some of you laugh for me. Some of you are holding it in, but that's okay. All right. So for tangent, it's restricted from negative to pi over 2 to pi over 2. So which two quadrants is that? So here's 0. So negative pi over 2 is right here. Positive pi over 2 is right here. So what are those two quadrants? Quadrant 1 and quadrant 4. Quadrant 1 and quadrant 4. So on your black bar sheet, right next to tangent, quadrant 1, quadrant 4. What's the only quadrant we have not gotten to yet? Quadrant 3. We're never going to have an inverse that's defined in quadrant 3. Okay? So if you start drawing triangles with inverse, when you're doing inverse functions, all of a sudden triangles keep happening in the third quadrant. No, you should be a little worried. Okay, so here we go. This is just the picture part, okay? So with tangents, at negative pi over 2 and positive pi over 2 and multiples thereof, we have vertical asymptotes. And it looks like this. And that's why they went from negative pi over 2 to pi over 2, because it's a natural break in the built into the tangent function. It naturally does that for you. It stops and starts, which is nice. Bless you. And then for the inverse, so instead of being vertical asymptotes, we're going to have horizontal asymptotes. So at pi over 2 and negative pi over 2. So the inverse is like this. Now remember, this one right here is concave up, so what's it going to be right here then? Concave down. So it looks kind of like this. Did I do that right? Yes. So it just kind of got laid on the side. And so now then we're going to switch our domain and our range. So what's our range for the inverse function? Or I mean our domain for the inverse function? All real numbers. And what's our range? Good. Good. Is that okay? Okay. All right. Are we getting close to this? All right. So, just like we did with sine and cosine, we're not really comfortable with it this way, so I'm going to let it equal x. And can I make it look a little more familiar? We're going to take the tangent of both sides. So that would mean you have negative 1 over root 3 equals tangent of x. Take the tangent of both sides, because the tangent and the inverse tangent cancel. Is that okay? Okay, tangents in quadrant 1 or quadrant 4. It's negative, so we're going to draw a triangle in 4. Opposite, adjacent, 2. Now, I wrote this one a little differently. Normally, I do root 3 over 2, 1/2, and 1. But is this the same triangle? Yeah. So what's the angle then? What's this angle? It's 30, which is pi over 6. But we went down, so it's negative pi over 6. Is that okay? Okay.
Wait, so for tangent, you can have all numbers
Mm-hmm.
that are negative?
Yeah. Here's the deal. Here's what I'm going to be happy with. If you got this on a test or a quiz and you just wrote down negative 1.2, am I going to be a happy camper? Yeah. And same thing with C. If you just gave me pi, I'd be happy. Whether it works or not right now, just understanding the tan and the inverse tangent cancel. Okay? The next ones are calculators. So can you guys do your calculator ones? Make sure you're in radians. Plug them in. We should have got those. Did they match up? Yeah, okay. By the way, Mr. McLaren's Spanish 2 class was very impressed at how well you guys paid attention. Because I have a few of them later in the day. They're like, wow, they were really paying attention. I'm like, yeah. People do that. It's really cool. Okay. Now these two, so remember when we had back at example 5, we got real number answers because we had real number ratios. The next two, we're gonna get algebraic answers. We're gonna have x's in there, okay? Because what did they give me as my ratio? X over 1. So here's what we're going to do. We're still going to replace the inverse tangent, but I can't replace it with x anymore because x is right there. So what are we going to replace it with? Yeah, I'm going to let y equal the inverse tangent of x. So what we're really looking for right now is what the sine of y equals. Really, that's what the goal is. Is that okay there? And so let's rewrite this guy. How would I rewrite him? Tangent of y equals x. So the y is now my angle. Well, the y is the angle. Are we okay to there? When we do these ones, when they give us the ratio, we're going to have x's in our answer. We're always going to assume we're drawing our triangle in quadrant 1. So we're always going to assume quadrant 1 on these, okay? So let's draw our triangle. So the tangent is opposite adjacent. And then how do we find our hypotenuse? How do we find it? Pythagorean. So our c squared equals a squared plus b squared. So x squared plus 1 equals c squared, but I don't want the squared, so what are we going to do? Square root. So it's x squared plus 1 for your hypotenuse. Is that okay? And we're asking about the sine of this angle. So the sine is opposite over hypotenuse. That's it. Is that all right? So let's, I threw the additional question. Yes.
So like for the y equals tangent -1, did you just flip x and y?
No, I took the tangent of both sides. So I don't want the tangent by the x anymore. I want just x equals, because that's the ratio of sides.
Okay.
So if you do this, as long as you do it to both sides, because what happens here? Cancel. Is that okay? Okay. So let's do another one. I know it says arc cosine, but really that means the inverse cosine, right? Okay. So what are we going to let the arc cosine of x be called? Y. So really we're looking for the tangent at that place. So how are we going to rewrite it? Cosine of y equals x. Very good. So which quadrant are we in? 1. Always assume these are in 1. And cosine is adjacent over hypotenuse. We've got to work this one a little bit, but it's not that bad. So 1 squared equals x squared plus b squared. We got to find that b side. So what would that be? 1 minus x squared equals b squared. So square root it. So the square root of 1 minus x squared. And so we want the tangent. So tangent is opposite, which is the side we just found, over adjacent. That's it. Okay. You have half an hour in here right now to work on this. It's a lot. But I will not see you again for class until Wednesday. So. I don't know if I should be